Alright, so welcome back to everybody. Once again, we are looking at logic, and specifically we'll be taking a look at Chapter 18, which deals with sentential logic, sometimes also referred to as propositional logic. Now, sentential logic is a much more recent form of logic than the one that we looked at last time, and it's also, as the name implies, more symbolic. The idea was that we wanted a logic that better approximated the way that we actually speak, because we don't go around saying things like all A's are B's and no B's or C's very often. We want to be able to approximate the way that we speak, and we also want to have it into a nice and usable form. So that's what sentential, what your book's calling sentential, sometimes also called propositional logic, is going to do for us. So the first thing is to know that the basic unit of sentential logic is the sentence or the proposition. So as we learned back in Chapter 2, the proposition or the statement is a sentence that makes an assertion, it makes a claim, it has a truth value. So we are dealing with a positive singular assertion. Okay, so the statement is a positive singular assertion. So for example, the door is open. Or perhaps the lights are on. Okay, so those are both examples of statements, singular positive assertions. They're making a singular claim. The door is open. The lights are on. In both cases, they are positive claims. Okay. Now, what we're going to do is for any basic proposition, we're going to have to assign a sentence letter. Now, of course, back in categorical logic, you saw the A, E, I, and O statements that we used, which had a very specific meaning. Here, the assigning of sentence letters is purely arbitrary. Normally, what we do is to use the first letter of the subject. So, for example, if I were going to symbolize the door is open, I would just symbolize it with the letter D. Or if I were going to symbolize the lights are on, I would just symbolize it with the letter L. Okay, very simple. It doesn't have to be, again, it's purely arbitrary. You can use A's, B's, and C's, X, Y, Z, whatever you wanted to use, as long as we know what that letter stands for. The only other exception is that each sentence has to have its own unique sentence letter. I mean, you can't have D standing for two things. So if you had the door is open and the drains are clogged, you couldn't use D for both door and drains. You'd have to use some other letter in that case. But generally speaking, this rule kind of applies and works well for us. So I would just assign a sentence letter to any singular positive assertion. So again, the door is open, I would call D. The lights are on, that is L. In addition to sentence letters, you are going to need to know 5 basic symbols. Actually, your book only uses 4, but there are 5, so I'll give you the other one just so that you have the whole set. The first is a matter of negation. Okay. If you want to deny something, to deny a claim, you want to say is not the case. Okay. The symbol that you're going to use is called a tilde. And it's a little squiggly line like that. Kind of looks like the little squiggly line that goes over ends in Spanish writing. But the tilde comes before the letter to basically deny it. And this is the only one that can stand. Of the symbols we're going to look at, the tilde is the only one that's going to stand on its own like this. So, if I wanted to say the door is not open, okay, We've seen the door is open is the D, but here we're denying it, so I'd put a tilde in front of it. It would become tilde D. The door is not open. If I wanted to say the lights are not on, right, that would be tilde L, okay? So it's very easy to use negation. You're just putting that tilde in front of the sentence letter, and that tells the reader that you're denying that statement. So, for example, if the door is open is true, then the door is not open would be false. Okay? Very simple, negation. Next, we have what's called conjunction. With conjunction, you're joining two or more statements together with words like and, but, yet. There are others, but those are the major ones, and, yet, but. And the symbol that we use for that is called the ampersand. Right? Looks like that. The ampersand. Now the ampersand is going to come between the two letters. Okay? So if I wanted to say the door is open and the lights are on, I would say the door is open, that's D. The ampersand is and, the lights are on is L. Okay? So the door is open and the lights are on, D ampersand L. So for a conjunction, it's just a matter of putting that ampersand between the two assertions. Okay? So that's conjunction. Use that for and, but, and yet. You can use negation with other forms. So suppose I wanted to say the door is not open, but the lights are on. Well, the door is not open is tilde D, but is still the ampersand. The lights are on is still L. Okay? So you can use the negation in conjunction with other symbols like this. So if I say the door is not open, it would be tilde D and the lights are on L. If I said the door is open but the lights are not on, then it would be D ampersand tilde L. Okay, you get the basic idea. What would happen, however, if I wanted to deny the entire statement? It is not the case that the door is open and the lights are on. Well, right here at the very beginning, I am denying the entirety of that statement. But here's the problem. If I simply put the tilde in front of the statement, then all that tilde is doing is denying the statement about the door being open. It's not denying the whole thing, which is what this is trying to do. And so to make this work, we need punctuation. Just like in ordinary everyday language, in logic too, you need punctuation. And the most common form of punctuation that we use are parentheses. And that's what I would need here. If I put parentheses around the D and L with the tilde on the outside, then that tells me that it's the total value of what's in here that's being denied, not the individual letter. Okay? So this is kind of a little bit of a tricky thing sometimes for people, but you've got to remember, where is the negation taking place? If the negation is taking place like it is here, in the beginning, before the subject, then you're denying the whole thing. You're going to need those parentheses. If, like we did before, the negation was after the subject, as in the door is not open, then that tells me we're denying just the statement about the door. Or if it were after the lights are not on, it would be just the statement about the lights that were being denied. Then you wouldn't need the parentheses. You wouldn't use them because you're just denying the individual parts. But if the negation comes before the subject in the very beginning like this, then it means you're denying the whole statement, which is why those parentheses have to be there to show that all of it, the whole value, is being negated. Okay, so keep that in mind. And as far as our translations and stuff are concerned, I'm pretty sure parentheses is probably all you're going to deal with. But beyond parentheses, we also have brackets and braces. Okay. And these might come into play later when we talk about truth values and things like this. But basically, this is the punctuation, parentheses, brackets, braces. And this is also the order of operations that you take things in, parentheses, brackets, braces. Okay. But again, for these translations, I don't think you'll have to use anything beyond parentheses. Okay. So those are the first two symbols, negation, the tilde, and conjunction, the ampersand. Next, we're going to have disjunction. Disjunction is an either-or statement, and the symbol that's used for that is a wedge. Okay, so lowercase v, kind of like a wedge. And again, it's going to come between the two sentences. So if I want to say either the door is open or the lights are on, I would see, well, the door is open, that's D, or is the wedge, the lights are on, L. Okay, D or L would be my symbolization of that statement. Okay. Again, what I said about the negation for the conjunction applies also for disjunction and for everything else. You could say either the door is not open or the lights are on, in which case you'd put a tilde in front of the D. If you denied the whole thing, you'd have it in parentheses with a tilde on the outside, and so on. So that's disjunction. It's either or, one or the other. And then we have a conditional statement, which is the if-then statement. Okay? If one thing occurs, then another thing will follow from it. And the symbol that's used there is an arrow. Okay? And again, it's going to come in between. Now, conditional statements are always the tricky ones because they have special rules associated with them. You may remember, hopefully, from Chapter 2, I think it was, that the if part of the statement is called the antecedent. The then part is called the consequent. The if part always goes before the arrow. The then part always goes after the arrow. So, if the door is open, then the lights are on. Okay. So if the door is open, the if part is the antecedent, the door is open, then that comes before the arrow. The arrow implies the if-then, and what follows then, the lights are on, is the consequent, and that goes after the arrow. So if the door is open, then the lights are on, that would be D arrow L. And that's the traditional way in which a conditional statement is written. However, sometimes you might see this. The door is open if the lights are on. Okay, it's a non-standard way of writing a conditional, but it's still a conditional. The point is, or the key is, find that if. What follows if is the antecedent. So this is basically saying if the lights are on, then the door is open, which would be L arrow D. So don't let them fool you if they give you something like that. And then, to make matters even more complex, the door is open only if the lights are on. Now, only if is different from if. What follows if is your antecedent. It comes before the arrow. What follows only if is the consequent. It comes after. So basically, the door is open only if the lights are on is the same as saying if the door is open, then the lights are on, which again would be the D arrow L. So your book may or may not try to trick you with stuff like that, but don't be fooled by it. If you see the if leads you to the antecedent. If you see only if, the only if leads you to the consequent. Okay, that's the conditional statement. The fifth symbol, which I don't think your book actually introduces to you, but it probably should have, is what we call a biconditional. A biconditional is a conditional statement that works both directions. And so you would see if and only if would be your key phrase. Again, it's combining together both possibilities, right? Again, if leads to the antecedent, only if leads to the consequent. So if I say if and only if, it means that the conditional works both directions. Okay? And the symbol here is a double arrow. Like that. And again, it would come between the two statements. So the door is open if and only if the lights are on. The door is open if and only if, goes both directions, the lights are on. And basically what this is, it's a shortcut of saying this. The door is open if the lights are on. So that would be if the lights are on, then the door is open. And the door is open only if the lights are on, D, then L. Okay, so if L, then D, and if D, then L, the conditional that works both directions, that's what's being symbolized in a shorthand through biconditional. But again, I don't think your book uses biconditional. I don't think it gives you any of those. But that is the fifth symbol, is the double arrow. Okay, so basically, again, you have the five symbols, which are the tilde for negation, the ampersand for conjunction, the wedge for disjunction, the arrow for conditional, and the double arrow for biconditional. Those are the symbols that you would use. And then, of course, there's the question of punctuation that comes into play. So, punctuation we've already seen is going to be used when negation comes at the beginning and you want to negate the whole value. I showed you that. It also would come if you're trying to bring three statements together. So let's say, for example, if the door is open, then either the lights are on or it is dark. So now, if we look at this, there are three separate statements here. The door is open. We've been calling that D. The lights are on. We've been calling that L. Now we have it is dark. Well, I would probably normally use D because of dark, but we've already got D for door, so you'll need to use something else. I'm just going to make it a T, it, right? Just because I is difficult to distinguish sometimes from the L if you write it too fast. But we'll make it a T, just, but it could be whatever. Now, we have three things being joined together. Because there are three things, there has to be parentheses somewhere. But where does the parentheses go? Well, remember, we start with if, and if always goes with then. Everything between if and then is the antecedent. Everything after then is the consequent. In this case, the consequent is itself an either or, a disjunctive statement. So the parentheses go around that disjunctive statement to show that the whole thing here implies or gives us the consequent. So I would write this D arrow and then in parentheses L wedge T, just like that. And that would be the proper symbolization for it. Again, you're not going to see it in terms of the in terms of what you're doing in the book. But if, let's say, you wanted to deny this whole claim, okay, so it is not the case that if the door is open, then either the lights are on or it is dark. Well, again, if I simply put the tilde in front of it, all that would do was to deny the statement about the door, and that's not what we want to do. We want to deny the whole thing. Because it's a longer statement, we've already used the parentheses, it means that we would have to use the brackets here. And that bracket would tell me that it's the total value, the total statement here that's being denied, not any individual part of that statement. Okay? So that's the basic idea. In braces, I mean, I can't even come up with a statement, a legitimate, reasonable sounding statement where you would ever use braces. But they are there. They do exist as the third form of punctuation. But again, for your homework, I'm pretty sure parentheses is all you're going to need. Brackets is something you might see, but braces, I don't know. It's probably going to be very rare to see something like that. All right. In your book, at page 370, in your book at page 370, you have exercise 18-3, and it basically wants you to symbolize. Don't worry about the true-false part of it yet. It says symbolize these forms. So the first one says it is not the case both that Jupiter is the largest planet and the Sun is a planet. Now, when you look at that, you'll see that right at the beginning, it is not the case. So you know that you're denying the whole value of it. That tells you you're going to need parentheses. Jupiter is the largest planet. I'm going to call that J. And is the ampersand. The Sun is a planet. So I would have the tilde, and then in parentheses, J ampersand S. Just like that. Okay? So it is not the case that Jupiter is a planet and the Sun is a planet. Okay. Number 2, either the Sun is a planet or if the Earth is a planet, then there is intelligent life on Mars. Well, in this case, again, there are three things that are presented to us. The Sun is a planet. I'm going to call that S. The Earth is a planet. I'm going to call that E. There's intelligent life on Mars. I'm going to call that M. And because there's three things, we know again we're going to have to use parentheses. Where do the parentheses go? Well, look at the beginning. We see either. Either goes with or. So everything between either and or is one part of the equation, which is a single statement. The sun is a planet. Everything after the or is the other half of the equation, which is that conditional statement. So you know that the parentheses are going to be on the second half of your equation. So the sun is a planet, S, or, which is the wedge, and then in parentheses, if the Earth is a planet, E, then, your arrow, there is intelligent life on Mars, M. So I would symbolize that S or, E, then M. Okay, and that's basically all there is as far as symbolizing these argument forms. But the homework also asks you to consider the truth value of these statements to determine whether these statements are true or false. To do that, I need to teach you something else, which is what are called truth tables. I do have a cheat sheet of truth tables for you on Blackboard as well. Under content, you'll find those. But we'll go through them here as well. A truth table is set up to establish what we call an all possible world scenario. We want to try to determine every possible situation. So, the number of sentence letters you're dealing with will determine the number of lines to your truth table. And so we're going to set one up here. This is for negation. And so with negation, I've got one statement here, A. A could stand for anything. The door is open, the cat is declawed, I mean, whatever you want to say. A stands for that. There's only two possibilities, right? Because we follow a system of bivalence. A is either true or A is false. So, what is the negation of that? Well, very simple. If A is true and you negate it, it becomes false. And if A is false and you negate it, it becomes true. Right? Very simple. The lights are on is true. And if that's the case, the lights are not on would be false. If the door is open is false, then the statement the door is not open would have to be true. Okay? Again, very simple. The negation implies that it's going to have the opposite value when you negate it. Conjunction. With a conjunction, there are two things you're joining together, so I'm just going to use A and B here. But that means there's four possibilities, because A and B could both be true. A could be true and B could be false. A could be false, B could be true. And A and B could both be false. All right, A and B. Now the thing about a conjunction, remember, you're joining those two statements together. And so the only time that a conjunction is ever going to be true is in that first scenario, when both sides are true. If A is true and B is true, the statement A and B is true. Okay? The lights are on and the door is open. So if it's true that the lights are on and it's true that the door is open, then the statement the lights are on and the door is open is true. But if there's any part of it that's false, it makes the whole statement false. Okay? The lights are on and the door is open. The lights are on is true, but the door is open is false. So the statement that I just made has to be false because part of it is. The only way that a conjunction is ever true is when all parts of it are true. Okay? So that's conjunction. Disjunction. It's going to be kind of the opposite of that. Again, there's two things we're joining together. Two sentence letters means 4 lines. So you could have both true, A true and B false, A false, B true, A and B both false, right? Again, you're playing out every possible scenario, A or B. Okay. Logic uses what we call an inclusive OR, which means that for an OR statement, a disjunction, to be true, it needs at least one part. Both parts could be, but at least one part has to be true. So the only time that a disjunction is ever going to be false is in the last situation. If A and B are both false, then the disjunction is false. If there's any part of it that's true, it makes the disjunction true. Okay? So if there's any part of it that's true, it makes the disjunction true. The conditional again, two things, so 4 lines, true, 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 false, false, true, false, false. And so if A, then B. Okay. Now, keep in mind what a conditional says. A conditional statement says that if the antecedent is true, then the consequent must follow from it, right? If the antecedent is true, the consequent must be true. If I release the marker, then the marker will fall. So, in that first situation, clearly the antecedent is true, the consequent is true, so the conditional is true. In the second situation, the antecedent is true, but the consequent is false, and that makes it false. That's easy enough to see. If my statement is, if I release the marker, then it will fall, I release the marker, so the antecedent is met, and therefore the result is that the consequent followed from it. So, of course, my statement was true. But if I say, if I release the marker, then the marker will fall, and I release the marker, but it doesn't fall, it floats in midair, then the statement I just made is clearly false, because the consequent didn't follow from the antecedent. That, again, makes perfect sense. The problem is when we look at the other two options here, because the rule of conditional doesn't say anything about what happens when the antecedent is false. It just says if the antecedent is true, the consequent must also be false. So what do we do in a situation like that? Well, in logic, we're going to give the benefit of the doubt and consider both of those to be true statements. Why? Because just because the antecedent is not met does not mean that if it were, the consequent would follow from it. We take the statement, if I release the marker, then the marker will fall. But I don't release the marker. I sit here and hold it. I'm not meeting the condition of the antecedent. However, that doesn't mean that if I did release it, that it wouldn't still fall, right? So if I let go of it, yeah, it's going to fall. But the point is, I'm not releasing it. I'm not meeting the condition of the antecedent, which is not at present allowing the consequent to follow from it. But if I did, the result would follow. And that's why this is considered to be true. So the point is that the only time a conditional statement is ever false is if the antecedent is true and the consequent is false. Any other time, it's going to be true. And finally, I'll go ahead and give you biconditional again, just so that you have the all of them. So with a biconditional, again, two things joined together. So true, 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 false, false, true, false, false. A, if and only if B. Okay. What you're looking for, essentially, with the biconditional is for them to have the same value. If they have the same value, they're true. If they have opposite values, they're false. So in the first case, if A and B are both true, the biconditional is true. In the last case, if A and B are both false, it's true. So if they have the same value, it's true. In the second and third, they have opposite values. True, false, false, true. Since they have opposite values, it becomes false. Okay? Now you want to make sure that you have these 5 truth tables in front of you to make easy reference to, because everything else that you do in this chapter is really going to depend upon your using those truth tables. And so, how do we use them? Well, first of all, we can use them in determining the truth value of an individual sentence. Let's say, for the sake of example here, that I'm going to consider A and B to be true, and I'm going to consider C and D to be false. Okay. Now that's just for what I'm doing right now. In the book, they're going to have you, figure out truth values from the actual scenarios, but I don't want to write out a bunch of words. We'll just do this straightforward here. So for these exercises, A and B is true, C and D is going to be false. So if I see, for example, A or not D, okay. Well, A, I'm being told, is true. D, I'm being told, is false. But I want to know what's the truth value of A or not D. Well, the first thing I recognize is that there's a tilde in front of the D. Well, if D is false, what is not D? Well, I look over here, right? A is just your placeholder for whatever letter or whatever phrase you're using. So if A is false, then not A would be true. So if D is false, not D is true. So the A is true, not D is true. True, true with the wedge. So I'm going to look on my disjunctive chart. I'm going to find the line where they're both true. True, true yields true. And just like that, we have determined the truth value of that sentence using our truth tables. If B, then not C. So B is true, C is false. Again, C is false, we have not C. So if the C is false, negated, it becomes true. So the B is true, the not C is true. True, true with the arrow, find the conditional. True, true with the arrow is going to give you true. And so we have the truth value of that statement. So here we have if C, then A or D. Well, we've got C, which is false. We have A, which is true, and we have D, which is false. Just like in mathematics, you have your order of operations. So your order is parentheses. If you have them, you start with parentheses. Then if you have it, brackets. Then if you have it, braces. And then you move on to your main operator. So in this case, we have parentheses. So we start with the parentheses, A or D. So A is true, D is true. We've got the wedge. True, true with the wedge yields true. So now I know that C is false, A or D is true, and we've got the arrow, so that's a conditional. So I'm going to find the line where the antecedent is false and the consequent is true. False, true gives me true. And so the truth value of that statement is true. Okay, So here's a little bit bigger one. We've got not, and then in brackets, we have in parentheses C and D, then B. So the C is false, the D is false, the B is true. So we start, again, order of operations, start in the parentheses. False, false with the ampersand. I'm going to look here, conjunction. False, false gives you false. Okay. That's the only parentheses we have, so now we move on to the bracket. C and D is false, B is true. So false, true with the arrow, that's conditional. False, true with the arrow gives you true. So everything inside the bracket works out as being true. But there's a tilde outside of that bracket, which means the total value of that bracket is negated. So when true is negated, it becomes false. Okay? So it's actually pretty easy. It's just a matter of plugging in the right concepts, the right ideas, in using the table here to be able to work these. So let's go back to those exercises on page 370. And I did the first two with you here. Again, page 370, exercises 18-3. And so we saw the first one. It is not the case that both Jupiter is the largest planet and the Sun is a planet. So we saw how to symbolize those. The next trick is to determine the truth value of that statement. Well, we have to use our basic knowledge. Jupiter is the largest planet? Yes, that is true. The Sun is a planet? No, the Sun is a star, so that's false. From here, we're just doing what I was doing a moment ago. We have J and S in the parentheses, so J is true, S is false. True, false with the ampersand. True, false with the ampersand gives you false. There's a tilde outside of that, so the total value is going to be negated. When you negate false, it becomes true. Okay? And so we know that the statement, it is not the case that Jupiter is the largest planet and the Sun is a planet. We know that statement to be true. The second one, either the Sun is a planet, or if the Earth is a planet, then there is intelligent life on Mars. Okay. The Sun is a planet. That's false. We've seen that. The Earth is a planet. That is true. There is intelligent life on Mars. Well, I mean, that's actually kind of questionable because there are some people who believe there has been evidence that maybe at one point there was. But as of right now, I'm going to assume that our general consensus is that there is not. So that being the case, I'm going to say that is false. Now, and that's, again, part of the problem with doing it the way the book does, is that sometimes there are these questionable statements like intelligent life on Mars and so on. But again, we're just going to do it in the same way. We start with the parentheses. The E is true, the M is false. True, false with the arrow, that's conditional. True, false is going to give you false. So, S is false, E then M is false. So false, false with the wedge, the disjunction, false, false with the wedge gives you false. Okay? And that's basically all there is to it. So the first part of the homework then that I'm going to give you is here on page 370. And I did the first two with you, so you should do 3 through 10. You want to write it out in this form, in that symbolic form, and then use the truth tables to determine the truth value of those individual statements. Okay. So that is the first thing, dealing with the truth value of those statements. The other thing we're going to do is to determine the validity of arguments. And we're also going to do that using truth tables. Now, again, you've got the truth tables. Hopefully you've copied them down from what we've done here. And you also have the little cheat sheet that I put up on Blackboard for you with those truth tables on it as well. So make sure those are in front of you, because I do have to erase this in order to have room to demonstrate the next things that we're going to be looking at. Okay. So now we're going to take an argument. I'm going to give you a very simple one to start with. If A, then B, A, therefore B. Now, I want to create a truth table to try to determine whether this argument is valid or invalid. To do that, I'm going to have to set up the truth table. Now, again, the number of sentence letters that you have determines the number of lines on your truth table. As you saw, if you have one sentence letter, you had 2 lines, right? True and false. With 2 sentence letters, like this is, there's 4 lines. 3 sentence letters would give you 8 lines. 4 would give you 16. 5 would give you 32. It goes up exponentially. You won't deal with anything beyond 3 sentence letters, so nothing beyond 8 lines. But this one only has 2. So we're going to set this up by putting first the 2 sentence letters, in this case A and B, and I'm going to list all of the possibilities. So A and B could both be true. A could be true, B could be false. A could be false, B could be true, or A and B could both be false. Then I'm going to take the argument and I'm going to write it across the line over here. So the first premise, if A, then B. Now, your book doesn't show you this, but I think it's a good idea to do it this way, because one of the problems that I find is that a lot of students, they try to work this like it's one big long equation, and it's not. It's 3 separate premises or 3 separate statements. So if you draw this line, it reminds you of that. This is your first premise. Here's your second premise. And then I do a double line between the premises and the conclusions, so that you can, it helps to remind you to keep, your conclusions separate. So now I'm just going to go through and I'm going to solve this line by line, just like we were doing before. Remember I told you A and B are true, C and D are false. The only difference is that now you're going to be using the chart that you've created on the side here to list all of the possibilities as the truth value. So on line 1, A and B are both true. So A is true, B is true. Look on your conditional chart. True, true with the arrow gives you true. Your second premise is A. A is just true. There's nothing to do with it. There it is. B is true. Again, there's nothing to do with it. It's just true. Second line, A is true, B is false. So the A is true, the B is false. True, false with the arrow is going to be false. A is true, B is false. Line 3, A is false, B is true. False, true with the arrow is going to be true. A is false here, B is true here. And on the last line, A and B are both false. False, false with the arrow is going to be true. A is false, B is false. Okay, so we have just completed a truth table for that argument. We've shown the situation in every possible scenario. Now we have to decide, is it valid or invalid? Thinking back again to Chapter 2, what is it that makes an argument invalid? Well, if all the premises are true and the conclusion is false, then it's invalid. So if there is any line where you have all the premises true and the conclusion false, it's invalid. To be valid is anything other than that. So if I go through this, on the first line, the premises are both true, but the conclusion is also true, so that's fine. On this line, the premises are not both true. There's at least one false premise, so that's okay. Again, here, there's at least one false premise, so that's okay, and the same thing on the last line. So there's no possibility here of having true premises leading to a false conclusion, which means that what we have is a valid argument. Okay? So that's a valid argument. A very simple example of one, but it's a valid argument. Okay. Now let me show you one that's invalid, another very simple one. In fact, it's very simple. If A, then B, B, therefore A. So since I didn't change the first premise, it's the same, so the truth values will all be the same. But when we fill in the second premise, it's B. So on line 1, B is true. Line 2, B is false. Line 3, B is true. Line 4, B is false. And the conclusion is A. So on lines 1 and 2, A is true. And on lines 3 and 4, A is false. So now we look at this. Line 1, there's true premises, but it leads to a true conclusion, so that's okay. Line 2, your premises are false, so that's okay. But here on line 3, you have true premises leading to a false conclusion. And because of that, we know that this argument is invalid. Okay? And that's all there really is to it. The arguments may get a little bit more complex than this, but that's the basic idea, is to simply look at what's presented here to you and say, all right, do I have any line where all the premises are true and the conclusion is false? If I do, it's invalid. If I don't, it's valid. Okay? So that really is it. Traditionally, most students find this to be the easiest form of logic, so I'm hoping that you guys will as well, and we'll catch on to it pretty quickly, pretty readily. But well, let me do a bigger argument with you. Okay. If B, then C or D, not B and C, therefore not B and D. In this case, you have three sentence letters, B, C, and D. So when you set this up, that means that your truth table is going to have 8 lines to list every possible scenario. So you could have true, true, true. You could have true, true, false. You could have true, false, true. You could have true, false, false. You could have false, true, true. You can have false, true, false. You can have false, false, true. Or you can have false, false, false. So those are all of the possibilities that you can derive from those 3 letters. Now, of course, you can just simply copy this down and just keep making use of it in that way. Long ago in logic, I needed to learn this, and I learned it, straight across just the way I did it that way. It was only a couple of years ago that a student actually pointed out to me something that I probably should have seen a long time ago and never did. And that is that if you look at it column by column, it's actually easier. See here in the first column, you have 4 trues followed by 4 falses. The second column, 2 trues, 2 falses, 2 trues, 2 falses. And in the final column, true, false, true, false, true, false, true, false. So it probably would have been a lot easier if you needed to memorize it, to have remembered it in terms of the columns like that, where there's a nice, neat pattern, rather than to have to just kind of memorize that whole big blob like that. But in any event, that's what it looks like when you have an 8-line truth table. Other than that, we're going to set this up the same way. So B, then C or D. Second premise is not B and C. And the conclusion is not B and D. Okay. So now we want to work this. Here's the thing. And you can, I always do this certainly with longer ones, but even with the shorter ones, there's no reason to do more work than you have to, right? We want to make things as simple as they possibly can. So you know that what you're looking for is a line where true premises lead to a false conclusion. So I usually start with the conclusion first. If the conclusion is true, you don't care what the premises are. They can't show it as invalid. But if your conclusion is false, then you want to work out the others. So that's what I'm going to do right here. All right. On the first line, B, C, and D are all true. So we have not B and D. So B is true, D is true. True, true with the ampersand is true. We negate true, it becomes false. All right. Because the conclusion has turned out to be false, we should look at the other premises and see if they are true. So, not B and C. B is true, C is true. True, true with the ampersand is true. Negate a true, it becomes false. So right there, without going any further, we know that this line is not going to make it invalid. We don't care what that is. So we'll move on to line 2. B is true, C is true, D is false. I'm kind of holding this up to make it easier for you and for me to keep track of what line we're on. If you're doing this at home on line paper, it's probably a lot easier for you to be able to see these things. But anyway, on line 2, B is true, D is false. True, false with the ampersand is false. Negate a false, it becomes true. So that's got a true conclusion, so we don't care about that. We'll move on to line 3. Line 3, B is true, D is true. True, true with the ampersand is true. Negate that true, it becomes false. So here's another possibility. We've got a false conclusion. So what about the premise? Not B and C. B is true, C is false. True, false with the ampersand is false. Negate that, it becomes true. We do that again. So B is true, C is false. True, false with the ampersand is false. Negate the false, it becomes true. So this is a possibility, so now we'll look at this one. B is true, C is false, D is true. Parentheses first. False, true with the wedge is going to give you true. True, true with the arrow is true. And so right there, without ever going any further, you can see true premises leading to a false conclusion. So I know, without doing any more of the truth table, that this argument is invalid. So again, don't feel that you have to fill out the entire truth table. Just fill it out to the point that you need to find whether there's going to be true premises leading to a false conclusion or not. If you don't have that, then it's valid. If you do, then it's invalid. Don't make more work for yourself than you have to. Right? All right, so let's take a look at page 373. And at 373, we have 18-4. which says, use the truth table method of determining the validity or invalidity of the following argument forms. All right. So I'm just going to work a couple of those with you, and then I'll turn you loose on some of them, and you can see how you do. So they start off relatively easy, and then they build, as you would expect, to a little bit more complicated statements here. But again, I don't think there's anything that requires, let me double check here. Yeah, there's nothing that requires you going beyond 8 lines to a truth table. So you're either going to be creating 4-line or 8-line truth tables. But anyway, I'm just going to take number 3 here to start with, which says not P or P and Q. Not Q, therefore not P. So that's the argument there at number 3. We have 2 sentence letters, P and Q. I always do the sentence letters when I put them up, I always do them in alphabetical order. So if you do that as well, it'll make it easier when we go to check them. If you don't, you'll still should get the right answer. It'll just maybe show it on a different line. But if you put it in alphabetical order, it'll come out the same way that mine does. All right, so since there's only 2 sentence letters, that means there's 4 possible lines. True, 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 false, false, true, and false, false. Okay. So not P or P and Q. That's your first premise. Not Q is the second premise. And your conclusion is not P. So we want to know, is this argument valid or invalid? I am going to start with the conclusion. On line 1, P is true. If we negate it, it becomes false. So we've got a possibility. Q is true. Negate the true, it becomes false. It's no longer a possibility, right? We can't have true premises leading to a false conclusion if one of the premises is false. So we'll move on to the next line. Here, P is true. Negate that, it becomes false. So again, it's possible. Q is false. Negate the false, it becomes true. Okay, so that's a possibility. So now we'll have to look at this line. Not P or P and Q. So the P is true, the Q is false. Inside the parentheses, true, false with the ampersand is false. P is true, negate that, it becomes false. So false, false with the wedge is going to give you false. So that line is not going to give you all true premises leading to a false conclusion. The third line, P is false, negate false, it becomes true, so that's okay. And the last line, P is false, negated, it becomes true, again, that's okay. So nowhere do we have the possibility of all true premises leading to a false conclusion, which means that our argument that is presented here is valid. And let me do one more with you here, maybe a bigger one. Let's do number 7. So number 7, we have if Q then, if Q then, not P then R. R marker's not wanting to work like it should. P then not Q. Therefore, P. Okay, so we have 3 sentence letters now, P, Q, and R. With 3 sentence letters, it means there are 8 lines to your truth table. So true, 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 false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, and false, false, false. First premise, if Q then not P then R. Second premise is R. Third is if P then not Q, therefore P. Now, even though there are three premises leading to the conclusion, don't let that throw you. It's still the same rule. You're looking for all premises to be true with the conclusion to be false. Now, remember what I pointed out to you earlier. In the first four lines, P is true. And in the last four lines, P is false. So, the first four lines we don't care about because the conclusion's true. It can't prove it invalid. We only have to look at the last four. That is what is going to, that's going to cut our workload down a little bit. Now, the next thing I would do, since I like to look for the easiest route, is to say, well, that second premise is R, so let's look at R by itself. On line 5, R is true. On line 6, it's false. Line 7, it's true. And line 8, it's false. Well, we're looking for all true premises leading to a false conclusion. If there's a false premise, we don't have to worry about that. So we've cut out that line. We've cut out that line. Now we're down to only two lines that we have to worry about. Right here, line 5, and right here at line 7. So this looks like a slightly easier premise. So let's look at that one next. P then not Q. So on line 5, P is false, Q is true. Negate true, it becomes false. False, false with the arrow is going to be true. So we've got two true premises. Let's see if we have a third one. So Q is true, P is false, R is true. In the parentheses, false, true with the arrow is true. We negate that, it becomes false. Q is true, true, false with the arrow is false. So we do not have all true premises leading to a false conclusion. So let's take a look at line 7. If P then not Q, so P is false, Q is false. Q is false, negated, it becomes true. False, true with the arrow is true. So again, we've got two true premises leading to a false conclusion. So let's see about the first one here. If Q then not P then R. So Q is false, P is false, R is true. Okay, so false, true with the arrow is true. Negate that, it becomes false. Q is false. False, false with the arrow is true. And so right there on line 7, you have all true premises leading to a false conclusion, which tells me that our argument here is invalid. Okay. So I am going to give you 2 through 10 even on these to play with. So the homework for this week, again, and it'll be listed on Blackboard as well, but I gave you 370 earlier. You're doing 3 through 10, and now at page 373, you're going to do 2 through 10 even. Okay? And of course, on Thursday, I will answer any questions you have. We'll work through the homework so you can check yourself. And you can let me know if there are any problems. Of course, feel free to email if you have any issues before this. Okay? So I hope you guys have a great time and have some fun with this. Once we're done with this section, then the logic stuff is kind of out of the way. And then starting next week, we'll be able to get into the critical thinking aspects. And I have a feeling the lectures will get a lot shorter when we get into that section. All right. So have a great week.